Did not beep. Oh, no, it's on.
Okay, so if I picked a red one, or if I picked earn 1, what can I pick? Red or black? What's the probability I pick a red one? It's like 4 out of 5, and black is 1 out of 5. If I picked earn 2, it could go, again, red or black. And you have 3 out of 5. 2 out of 5, perfect. If I picked a earn 3, red or black, 3 out of 6. 3 out of 6, perfect. And then they want to know probability it will be red. So we want to know these solutions here. This one, and that one. So we need to find them. So here, this one is 1/3 times 4/5. This one is 1/3 times 3/5. This one is 1/3 times, 3/6. I'm going to simplify it 1/6 just because, 1/2, it'll make my life easier later on, because the denominators are not all the same, which is a big pain in the butt. So this one will end up being, again, you multiply the numerators, you multiply the denominators when you multiply fractions. Or you could just do this in your homework. On your homework, you're going to putting this in as a decimal, so you can just multiply those and do them on your calculator and just give yourself at least 4 or 5 decimals, because it wants you to round them to 3 decimal places when you put them in. So you want to have at least 4 or 5 decimals as you're adding them, in case things carry over and do weird things, because you don't want to, because of rounding, you don't want to be off. So you can just find these as decimals if you want, but again, give yourself 4 or 5 decimal places, and then add them, and then round before you put your answer in, because your homework wants it in 3 decimal places, not 3 sig figs. Those are different. But I'm going to say, but here's the deal. How can I get a red marble? It can be earned 1 in red, or it can be earned 2 in red, or it can be earned 3 in red. Or as we add. So you're going to add these. And you'll end up getting, we need to put them in like terms first. So I would do it like this. I do 8 out of 30, 6 out of 30, and 5 out of 30. So you would end up with 19 out of 30 as your final answer. Did anybody actually get the actual number for that in decimal?
0.634.
634?
There's some debate.
No, it's 0.633.
33? Hey Google, what's 19 divided by 30?
What do you get for each?
Google, what's going on? 19.
Yeah, I just rounded it here.
19 divided by 30. Yeah, 0.633. So again, give yourself, if you got 0.634, make sure that you gave yourself 5 decimal places, 4 or 5 decimal places, and then add them, and then round. Otherwise you could have some issues because of rounding error. Okay. Who got 0.34, 0.634? Did you round to 3 or did you round to 4?
I just multiply the fractions and then I can just enter each answer and I did it that way.
Okay. This alright came up. Oh, that's right. No worries. Aha. Rolling 2 standard dice. Add the numbers. What's probably getting a number larger than 9 for the first time on the 3rd roll. So when you go to your homework, do I have it up there? I don't have it up there. Darn it. If you click on the Help Me Solve This, it will give you a little table of all the dice options. And if you look at the little table, or you can look in your notes, it's in your notes as well. We have some dice in here. It's right here, right? The little dice spot right there on the 3rd page. Which ones have a sum of larger than 9. So is 9 larger than 9? No. So you have to do the sum of 10 or more. So you've got 1, 2, 3, 4, 5, 6 of them that are larger than 9. So this is a probability is 6 out of 36, which I'm going to simplify to 1 out of 6. Okay. Now, here's the thing we're looking at. For the first time on the third roll, we're not done yet.
I'm lost.
Okay.
I don't know how you even got the 6 out of 36.
Okay. Hold on. Okay. Okay, here they are. So here are all the ways of rolling 2 dice, right? You can roll a 1 first, or a 2 first, or a 3 first, or a 4, or 5, or a 6 first. And the second dice could be a 1, 2, 3, 4, 5, or 6. So this is all 36 ways. How many ways are there? 6 down. 1, 2, 3, 4, 5, 6. 6 across. So 6 by 6, 36 possible. Or you just count them. Which ones are more than 9? 1, this guy, this guy, this guy. These 2 and this one. So these 3, those 2, and that one. Yeah.
When I was doing the homework, with the thing that was thrown in the office, how it says the first time on the third rule.
I know. I'm getting to that.
Okay.
Yeah. So, but we're want to get past this first part. So this is where the 6 out of 36 comes from. Okay, everybody good with that part? Yeah.
I get lost when because I start thinking about the only thing we care about is that the sum is greater than 9, right?
Yep.
So wouldn't it just be we're looking for 10, 11, 12, which is 3
Yeah.
possibilities
No.
of 12?
No, not at all, because 10 is more likely than 12. They're not equally likely. Each one of these is equally likely, but there's, how many ways are there getting 10? 3 ways. How many ways are there getting 11? 2 ways.
So there's way more ways to get a 7 than there is a 12.
Exactly.
Okay.
So because of that, you can't just do that, because otherwise it'd be like 1 through 2 through 12. There isn't a 1/11th chance of getting a 7. It's way more. Yeah. Good point. Good thing to point out. So you have to count how many ways come in this way. 6 of them out of 36 total. Is everybody with me on this part? So these 6. So 6 out of 36, which I'm going to say is the same as 1/6. Now let's go back. Let's look at this part. Larger than 9 for the first time on the third roll. You guys, heads up. If you do it for the first time on the third roll, that means that you didn't do it on the first roll or the second roll. Do you guys understand what I'm saying? If your first time was on the third roll, it means you failed on the first one, you failed on the second one, you succeeded on the third. Yes?
Yes, that means
Yeah, so that means it went like this. You did it 3 times and went no, no, yes.
20 divided by 36.
So what's the probability that you, or what's the probability you get it?
No,
What's the probability you have a yes?
6 by 36.
6 over 36, so I'm just going to simplify it to 1/6. Everybody's all right with that?
Yes.
What's the probability I don't get?
30 by 36.
Yes. 30 by 36, or I'm going to make it, I'm going to simplify it to 5 out of 6. Because that makes my multiplying easier.
5 by 6.
Okay? Everybody all good with this? So, and then it has to be no and yes. Everybody understand that? That's the tree. The first branch was, I rolled, did I get it or not? No. Then you go to the no branch. Do I get it or not? No. Did I get it? Yes. So it, no, and yes, and we, try it again. And we multiply. Everyone say it together. And to multiply. Ready? 1, 2, 3. And we multiply. If you do not get that and really have that firmly in your head, you are not going to pass that test coming up in a week. You have to know this. And we multiply. So, no, and yes, multiply. 5 times 5 times 1, 25. 6 times 6 times 6, 216. I didn't do it as a decimal place, it doesn't matter. It's all good. Who got it and got a decimal? What'd you guys get?
0.115. If you round it, 0.116.
116. Yeah, 116 was what people got. Yeah. All right. So the next one we should look at is this one. Corey, H, go ahead and read.
Probability of getting at least 1 is the same as 1 minus the probability of getting 1.
Is 1 minus, yeah, keep going.
Complement rule, probability of A equals to 1 minus the probability of A.
Complement. Mm-hmm.
And the probability of rolling 3 dice and getting at least 1 4 is 1 minus probability of no 4s.
That's good. Perfect, thanks. All right, so remember we did this with the 4s last time? At least 1 4. If I roll it 3 times, at least 1 4 means I've rolled 1 4 or 2 4s or 3 4s. You find all those and add them all up. Or you find the probability of no 4s and subtract from 1, which is way easier. Especially because no 4s, there's only one way of getting no 4s. It means no, no, no. The alls or the nones are super easy because there's only one way of getting them. Yes, yes, yes. No, no, no. You have to worry about yes, no, yes, no, yes, yes, all that other stuff, right? It's just there's only one way of doing all or none. So no 4s, super straightforward. Just have to find the, you need to figure out what's probably of getting a 4 and the probability of not getting a 4 3 times and subtract that from 1. So I'll give you guys a couple of minutes to work on problem. Are you guys all done with them? Who is done with problem number 1 on the quiz? Who needs like 30 seconds? Okay, we'll go ahead and do it. Looks like we're done. If not, then you better take good notes. Here we go. All right. So airport has a 71.6% on-time rate. What is that in decimal form? 0.716. Great. What's probably they're all on time? So he takes a flight. What's the probability his flight is on time?
0.716.
What's probably her flight is on time?
0.716.
What's probably her flight is on time? 0.716. Great. So we need his flight to be on time, and her flight, and we... Thank you. Yes, so much better. Thank you. So 0.716 times 0.716 times 0.716. That's the all, right? 0.716 times 0.716 times 0.716. And you guys got, which is the same thing as 0.716 to the 3rd power. And you guys got what?
0.267
0.267. Great.
or 667.
367. Okay, good. None were on time. So none were on time. That means no, no, no. What's probably his plane was not on time?
0.284.
What's probably his plane was on time? 0.716.
So 1
What's
minus
0.716? So probably his plane was not on time. So probability late is 1 minus 0.716. 0.284. Everybody good with that part? So his was late, not on time. Hers was late, and hers was late. Find that. If you haven't found it, find it now. Take 15 seconds. Go.
You were right when you were saying that earlier when they said on minus so that's the thing.
That's it.
So the answer is
Did I?
point two. Wait, oh wait, hold on.
All right, what'd you guys get for this one? You did 0.284 to the third power, and you got 0.02?
Point zero two eight four.
2, 3, 4?
Times
What?
6 over 12 over.
What?
Oh, I'm just kidding.
0.023. Okay, good.
The answer.
All right, so, let me point out something else while I have you guys here. Because this will happen on the exam, and it'll happen in the homework. Okay, everyone, look, you guys quiet, listen up. So, at some point, you're going to have something where it's some small number raised, and see how this one is 1.43? So, can everyone see that? Yes. I don't think I can make it bigger. I can try. No, I can't. So 1.43 means 143%. That's impossible. Everybody on board? Anytime you have a number bigger than 3, 7.6, 7, 2.49, then you should be suspicious because you can't have 200% or 700%. You should be looking for this little E. There better be an E negative something on the end. You guys see that E negative 8? What that means is make it smaller by moving the decimal place over 8 spots. So the easiest way to do that is to put, if it's E negative 8, add 8 zeros in front, put your decimal place after the first 0. That's one of my students taught me that. I was like, oh, that is a lot easier. Right? So E negative 8 means add 8 zeros in front, decimal place goes after the first one. Everyone on board? Okay, because that will come up, guaranteed. All right. At least one was on time. So this means this is a probability. This is equal to 1 minus the probability that it was that. Okay. So I'm going to use one time. You guys focus. The complement of at least one is none. Either I have at least one sibling or I have none siblings, no siblings. Either I have at least $1 in my pocket or I have none, no dollars in my pocket. So here, the easiest way to do this is where it says at least one, just cover up the at least and make a capital N here. None was on time. Can I see that? Just replace this at least with a capital N. None was on time. None was on time means that was none were on time, or all were late. And you should probably write it in, probably none on time. So then you kind of have that extra step in there. Because sometimes you have to wrap your head around it, and we have to find, probably they're all late. So you have to say none on time is the same thing as all late, right? Or like, probability that none were girls means that all were boys. And you have to kind of like do that sort of mental flip-flop in your head, right, to figure out how those two things line up. And then this ends up being 1 minus none on time. This one here, 0.023 or 0.977. All good? Great. Perfect. So a couple quick things, law of large numbers. If you flip a coin 10 times, why am I reading? Ivana, read. Great. Exactly. So if you do it often enough, longer and longer, then eventually, you might get some big variance in the beginning, but eventually the probability will get closer and closer to the true probability. Do not misinterpret it this way. People do this all the time. That does not mean that if the coin has flipped up and come tails 4 times in a row, that's more likely to come heads next. It's still, the very next flip is still 50-50. The coin does not know that, oh my gosh, I came tails the last 4 times, I need to come heads now. It has no memory. right? It's still going to be 50%. What it does mean is that if you do it thousands and thousands of times, if you add all those together, eventually that's going to get closer and closer to 50%. And the mistake people make in the casino is it would come like player, 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 and people would rush over and put a big bet on banker because it must come banker next. It's come player a whole bunch of times. Still just as likely 50-50 either way, just about. So don't lose all your money doing that. I did that once. Did I tell you guys about that? I should tell you guys about that. So, second time I played Baccarat, and like after that I never really, Anyway, so I had first time went pretty well, so I was excited. Came back, I had like $600 or something like that. I bet 25, I lost. I bet on banker, lost. 25, bet on banker, lost. 25, okay, so get my money back and you bet 50. 50, banker, lost. 100, banker, lost. $200, banker, lost. It came banker 1, 2, 3, 4, 5 times in a row. And I lost $400, like that. And I was like, okay, I'm done. So is it likely to happen? No, but what it does, it can happen, right? Each flip is still 50-50. So, you have to kind of bear that in mind, that totally is possible, and that cured me of playing Baccarat. Okay. House always wins in the long run. They really do. All right, so we're doing really well. Let's go ahead and take a break. We'll take a 10-minute break, I think, because